Hey guys, today we're going to start taking a look at graphing linear inequalities. So before we actually get into that, I want to point out a few key points that will help you be successful. So the first thing I want to remind you of is if we have an equation in slope-intercept form, which is y equals mx plus b, we can use that to either compare graphs or test to see if an equation matches a graph. So let's look at that. Let's say we have y equals 3x plus 2. So just as a quick reminder, let's sketch a quick graph. And we don't need too many points on this. Here we go. So the y-intercept would be the b, which is positive 2 in this case. And this line, let's make it y equals negative 3x plus 2. So if I have a negative 3 as the slope, that means I rise down 3 and run 1. So I'm going to start at my b and I'm going to go down 1, 2, 3, run 1. Down 3, 1, 2, 3, run 1. That's how you graph a line using y equals mx plus b or your slope-intercept form. So keep that in mind in today's lesson. The next thing I want to remind you of are inequality signs. So if you remember when we graphed inequalities, we had less than or equal to, greater than or equal to. And you can pause the video and write the words if you want to. Remember, if we didn't have a line, there was an open circle. Well, when we're graphing lines, if there's no line under it, it will be a dotted line. And I'll show you what that means later. If there's a line under it, like less than or equal to, you would graph the equation using a solid line. Same thing with greater than. Greater than would have a dotted line, and greater than or equal to would have a solid line. And then the third point I want you to remember is how we did test points. So let's use the equation we had earlier. We had y equals negative 3x plus 2. And let's say I wanted you to test the point 4, 12. The way we tested that is we plugged the x and the y into the equation. So that would be 12 equals negative 3 times 4 plus 2. So 12 equals negative 12 plus 2, so 12 equals negative 10. So we would say that is not a solution. Well, in this lesson, we're going to change this symbol right here to an inequality sign, okay? So I want to change this to an inequality sign. It's the same exact stuff, except watch what changes. So I'm going to go back to this original equation, and I'm going to rewrite that as y is greater than or equal to, let's just do greater than. Y is greater than negative 3x plus 2. So for these, first I decide solid or dotted line. So looking at this, there's no line under it, so that's going to be a dotted line. So what I would do is I would do this. Boom, 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 boom. I would still graph the line just using a dotted line. And then we have to use test points to decide which side of the line that we graph. Me personally, I always start with 0, 0, if it is clearly on one side of the line. So let me show you what I mean here. Here, 0, 0 is clearly to the left of this line. So my test point is going to be 0, 0. That's the origin. That's just my go-to. You can use any point that's clearly on one side of the line. So my y is 0 is greater than negative 3 times 0 plus 2. So 0 is greater than, negative 3 times 0 is 0, and 0 plus 2 is 2. Is 0 greater than 2? No, it's not. So that means that side of the graph is not my solution, but rather this side is going to be my solution. Okay, so again, use your y equals mx plus b to graph your line. Use less than or equal to, greater than or equal to decide solid or dotted line. And then use a test point to decide which side that you shade. Now let's look at the types of problems you'll see in this lesson. So look at the first example here. So it says which inequality is represented on the graph below. So I want you to pause the video and do just a rough sketch of your graph. So if I were doing this, I would graph this right here. I notice it goes to 8. Okay, so this is at 0, 8, and the x-intercept is at 4. So I would write 4 here. I notice it's a solid line, and I also notice that the right side is where the shading is. Now let's pick our choice. So watch this. I notice that every single one of these equations is the same. They all have the same. Remember, I use y equals mx plus b. They all have the same exact y-intercept, which is 8. They all have the same exact slope, which is -2, so it should go down 2, run 1, down 2, run 1, which it does. So now I need to decide, should it be solid or dotted? Well, it's a solid line, so that means I can mark out A and B based on the inequality symbol. Now I do my test point. What did I say I like as my test point? I always like 0, 0. Well, let's see. Since they have it shaded, let's find something that's in the shaded area. 5, 1. Remember, you can choose the point. So I'm going to use 5, 1 as my test point since it's in the shaded area. So I'm just going to have y is greater than or equal to -2x plus 8. X is 5, y is 1. So 1 is greater than or equal to -2 times 5 plus 8. So 1 is greater than or equal to -2 times 5 is -10 plus 8. 1 is greater than or equal to -2. Is that true? So I noticed that that is true. That's a true statement. 1 is greater than or equal to -2. So that means C is my answer. But I want to show you what would have happened if we had gotten a wrong answer. So let's test D. So D is y is less than or equal to -2x plus 8. So let's test that same point. Y was 1 is less than or equal to -2 times, 5 plus 8. Is 1 less than or equal to -10 plus 2 is -2? That's not true. So D is not the equation of this, or I'm sorry, the inequality represented on the graph. So that's one type of question. You may have a graph and be asked to choose the correct inequality. Let's look at another example. In the next example, they give us the one equation and ask us to test the graphs. So again, one of the key points that we talked about was y equals mx plus b. So the first thing I usually test is my y-intercept. I use that first to rule out anything. In this case, because I notice all the graphs are different. So when I look at A, yes, 2 is the y-intercept. What about B? Yes. C, oh, they all have a 2, so I can't use that. Now I'm going to look at the slope. So I notice, first of all, that slope is negative. So which of these have positive slopes? Well, B has a positive slope, so it's out. It's out. C is negative, that's okay. D also has a positive slope, so that's out. So now we're down to A or C. And it looks to me, honestly, like A and C have the same exact line, just the shading is in a different place. And they both have this right here, which is another key point we look for, the line should be dark, okay? So I told you my favorite go-to is the point 0, 0. So I'm going to test 0, 0. If it makes this inequality true, then A will be my choice. So let's test 0, 0. So here's my inequality. Y is less than or equal to negative 1/3 x plus 2. Y is 0 is less than or equal to negative 1/3 times, in this case, x is 0 plus 2. Is 0 less than or equal to 2? Yes, it is. So since 0, 0, which was my test point from A, the shaded part on A, since that made it true, my answer is A. Now let's take a look at another example. In the next example, what do you notice about that equation? Well, it's in standard form. So before I actually test that, I want to get it into slope-intercept form. So that's the first thing I'm going to do. So I have 4x plus 6y is greater than or equal to 10. So I'm going to subtract 4x from both sides. So I'm left with 6y is greater than or equal to negative 4x plus 10. I do want to remind you, if I were to divide by a negative, remember we flip that inequality. But in this case, I'm dividing by a positive, so that doesn't flip. So y is greater than or equal to negative 2/3 x, and 10 over 6, that will reduce to 5 over 3. Let's see, 5 over 3. But it looks like since I'm using this to evaluate, that's almost at 2. So it's about 1 2/3. So now I'm going to test my key parts of my slope-intercept form. So first, I like to test my y-intercept, which we said was about 1 2/3. And I notice every single one of these has the same exact y-intercept, so that doesn't help us. Next, I'm going to take a look at my slope. I notice my slope is negative. So automatically, I can get rid of A and B. Well, there's another reason A and B are wrong, or not good choices. They have dotted lines. When looking at the inequality sign, they should have solid lines. So now let's look at C and D. So it looks to me like the only thing that's different now is the shading. So I always look for 0, 0. It's just nice, clean numbers. So I notice C has 0, 0 shaded in. So I'm going to use 0, 0 as my test point. So 0 is greater than or equal to negative 2/3 times 0 plus 5/3. So 0 is greater than or equal to 5/3. Is that true? Is 0 greater than about 1.7? That's not true. So that means that C is not the correct graph, but rather D. So bottom line, I'm using my key points of my y equals mx plus b, test your slope, first test your y-intercept, then test your slope, then check for a dotted or solid line. And then if you have to, do a test point. So those are the main points here. Then you're going to run into something that looks like this. Here is our fourth and final example. I didn't label the others, but this is our last example. Which ordered pair are solutions to the linear inequality? Well, we've been doing test points this whole lesson. These are just test points, and the one that makes the inequality true is a solution. So first, I'm going to test 6, 0. So I've got y is less than or equal to 5x minus 4. So in this point, y is 0 is less than or equal to 5 times, in this case, x is 6 minus 4. So 0 is less than or equal to 30 minus 4. Is 0 less than or equal to 26? Yes, it is. So, yes, this is a solution to that inequality. Now let's test the second point, which is 0, 4. So I'm going to test x, or x is 0, y is 4. Go back to the original inequality, 5x minus 4. Let's see, in this case, y is 4 is less than or equal to 5 times x is 0 in this point minus 4. So is 4 less than or equal to 0 minus 4 is negative 4? Is it? No. 4 is actually greater than negative 4. So no, this second point is not a solution to that linear inequality. And last but not least, let's test the point 1, 1. So 1 is x, or x is 1 and y is 1. So let's go back to that inequality. Y is less than or equal to 5x minus 4. Y is 1 is less than or equal to 5 times 1 minus 4. 1 is less than or equal to, well, 5 times 1 is 5, and 5 minus 4 is 1. Is 1 less than or equal to 1? Well, it's equal to. So yes, the point 1, 1 is a solution to that linear inequality. So one more time, make sure that you use your key points to help you with this. Use your y-intercept, your slope, test your inequality sign for a dotted or solid line, and use test points to test the shading or if a point is a solution to the linear inequality. Use your notes, and I'll talk to you guys later. Bye, guys.